Hello everyone, this is my project, which is clinical chest X-ray dataset project. So, to detect different lung diseases with the help of deep learning, I'm working with NIH chest X-ray dataset from Kaggle, which has more than around 377,000 images collected, around 60 from around 65,000 patients. Each image can show more than one disease, so it's a multi-label problem. The main goal of my project is to train a model that can identify and classify these diseases automatically and accurately. So far I have finished collecting and organizing the data, removed some patient information to keep it anonymous, and started exploring the dataset to understand its patterns before I move on to deeper analysis and model training. So, yeah. So moving to the second slide, here's the overview of my data set. You can see, and for going to the data cleaning process, I converted some medical images which are in the form of DICOM format to PNG, which is standard for image processing. And not just that, because they are useful to handle and faster to progress process. So I also resized all of them from 224 by 225 pixels so that they are consistent when using with the model. Then I removed some extra columns and any details that could identify a patient to in order to maintain privacy. So while cleaning, I found very particular problems like patient ages being 400 years and old, which clearly isn't possible. So I noticed differences in large in image brightness and contrast because the X-ray came from different machines. To fix that, I started applying normalization, which I need to explore in by the next week. So going to the exploratory data analysis of this project, we can see that we are in the analysis stage. So I looked at few how the diseases and patient details are distributed. The most common label is no finding, which is like over 60,000 no finding images, which shows that the data set is very imbalanced. Other frequent conditions include infiltration, effusion, atelectasis, nodule, mass, etc. So, and some other diseases often appear together in the same X-ray. So, I found that many patients are between the age of 40 to 60 years old, and there are fairly even split between males and females. I tried to visualize this pattern here. You can see that the frequencies. Uh, by the next week, I intend to visualize these patterns like using bar charts and histograms for the better understanding of how my data looks. I also started to look into radiomic features like texture and intensity to see how the structure of diseased lungs differs from the healthy ones. So, going to the radiomics part, uh, I just didn't start it completely because I need to explore various methods to approach this radiomics. So I plan to do early testing using DenseNet 121 model just to set a baseline. The model should, from the paper, considering from the paper, it should do pretty well with the paper explaining around 0.85 to 0.91 accuracy AC score. So I need to move forward with the plan to start calculating radiomic features from X-ray images. These radiomics basically means extracting extra details from texture, shape, brightness, patterns that we discussed in the paper review, which are not visible to these patterns are not visible to the human eye. So these features, I'll have to combine them with the features from the pre-trained deep learning model using transfer learning. By blending these two information, I expect the models that I'm going to use in future should be more accurate and more explainable. So looking at the challenges, right now, biggest challenges are the differences in image brightness between hospitals and imbalance between the disease categories. Some X-rays are darker or lighter, which can like confuse the model. and few diseases have far fewer examples than others. Like we can see in the visualization that there is a high class difference from, let's say, hemia. We just have 227 examples. Considering effusion, we have over 13,000 examples. This can severely, cause class imbalance while classification of our model. And yeah, radiomic features, which the main topic of our project, are also sensitive to image quality. So I'm working on making my pre-processing steps more reliable for my model building. So in next few weeks, I plan to finish data exploration, extract the radiomic features, and build a combined model using transfer learning. So finally, I have a concern that my model should be able to process the images I am feeding it. So if not, I have to significantly downscale number of images. It can affect my performance, but it can overall give me an idea of how my model is working and what improvements I can do. So yeah, that's it. Thank you.